Hello everyone, and thank you for joining me on this lecture for machine visions. This is going to be mainly an introduction to our upcoming series here on machine vision systems. Our objectives of this kind of lecture video would be to define kind of what the vision system is, talk briefly about the history, where it came from, what its conceptual ideas were. We're going to kind of relate to how the understanding of the science of the eyeball versus how computers or machine vision work as well, and then we'll talk briefly about the applications. Applications will definitely hit a lot more on in upcoming videos, but in this particular one, we'll briefly discuss some of those applications. So, kind of a simple definition is it's a field or science of providing machines with vision, so some way to see a part. You'll find that a lot of experts in this field will tell you that machine vision could be an art or a science, and it's highly debated throughout the community as to whether it truly is an art or a science. You'll do a lot of discovering that most professionals will agree that it's kind of a both in some respects. Um, so we'll talk briefly about the history here. So it really kind of became a conceptual idea in the 1960s when some MIT scholars got together and saw a need to have a machine basically view something or inspect it or at least see it. It was kind of the grandfather of the AI technology that we see today was kind of its need, and the concept and the idea was really developed by Marvin Minsky there at MIT. Obviously, what was initially machine vision as compared to what it is today has come a long way, and it's still coming a long way. Kind of like a couple of our points here are we saw that the machine vision really started to kick off in the 1980s in manufacturing facilities as a type of inspection system, and it really became popular in the 1990s, especially with camera systems such as DVT, which would be the precursor to what is today Cognex. Um, in the 2010 era, we began to see a lot more of 3D image processing. So we were able to compile multiple images together into a 3D image. We see that a lot, especially with Keyence and Cognex, especially with some of their 3D image processing systems using laser profiling as well as 2D cameras into the system. So we'll talk a little bit about human vision and how it kind of compares. We'll briefly discuss the human vision to a very basic understanding, and then kind of compare how that goes into like how some of the MIT scholars put that into basically what is today machine vision. So in the human eyeball, we have things like the eyelid, the cornea, the pupil, lens, retina, and then the optic nerve, and obviously your brain. So you have parts such as the eyelid, the cornea, and the pupil that all kind of work together to control the amount of light that your eyeball lets in. And then the lens will adjust the image so that it's in a clear state, if you will. And obviously, some of us wear glasses because our lenses don't quite adjust to those images correctly. So we have to have a correcting lens that allows it to be seen in better focus. The retina is going to be basically the piece that's your photon receptor. It also determines whether you can see color or not. So depending on whether you have the rods and cones that support those color images and stuff, then it's going to allow those photons to be corrected on the retina based on those rods and cones so that it can see those color images. Then you'll have the optical nerve that will transport the image as electrical impulses over to the brain, and the brain processes it so that we are able to understand the image. So we kind of briefly went over that. Um, so understanding though that in all image systems, kind of the key point on this slide that we really need to pay attention to is images reflect light. So in all things that we see in 2D, but our brain puts it into an understanding that we can understand it in 3D. But what we really see is the light being reflected or refracted or diffused on the material that we're seeing. And we'll talk more about that when we get into lighting in some upcoming videos. So obviously the critical parts to the machine vision that we really need to pay attention to is the light, the lens, which would include the aperture, so allowing how much light comes in and what doesn't. The sensor, so that would be your photon sensor or your vision sensor that's taking the photons and converting them into electrical energy, and how that may be is between a CCD or a CMOS sensor. And again, we'll talk about those in upcoming videos and how those two different sensors convert that into a different electrical impulse. Um, some people will call this a different thing. You'll have what I like to call is the umbilical, or it's some type of cable that's transmitting it from the camera sensor itself into the image processing unit. Um, and then you'll have the image processor. So depending on what kind of camera you'll have, you might just have like a computer that's the central processor. You might have a smart camera that's got it all linked into one system. You might have a computer with an image grabber because you have that type of cabling transformation or sensor that needs that kind of image. So um, just kind of depends on that, and again we'll talk more about that in upcoming videos. And then you'll have the outputs, and the outputs would be, good image, bad image, have we met the criteria we're looking for. If we're doing object character recognition, this would be our output of we saw this particular type of code that we're looking for, or something along those lines. And again, just kind of a reiterating what we've already talked about, the light would come into the lens, and then the image chip or the image processor, or excuse me, the imaging sensor itself would absorb and convert the photons to the electrons. And back to kind of like we talked about the eye a little bit too, is that's critical because in some sensors we'll have an RGB, so red, green, blue type of filter over those photon sensor pieces, which would be the pixels, mind you. And so some of those will filter out what type of light is allowed to be absorbed into that. And so that's kind of a critical thing that, again, we'll talk about in upcoming videos. So some of the applications that we often see is like a process control. So robotics would be something like with more like your 3D imaging, or even a 2D imaging. So you might have like a palette of product when the robot is picking product off that to put it on a conveyor belt, maybe stacking on a bigger pallet or something along those lines. And so it's using a 2D image to see it from a above piece, and it's able to pick and point what needs to be picked up in those spots. You might use it for like a quality inspection, so is presence absence of a piece of equipment on there, or something along those lines. Or are you measuring maybe the diameter of a circle on maybe a logo or something along those lines. Part detection. This could be part detection as well as part orientation. So are we looking at threads on a bolt, or is the bolt even present on the conveyor belt when it should be? Or maybe like on a circuit board, is the capacitor in the presence on the circuit board, or is it not there? Something along those lines. And then you come into, and I kind of wish we would have put this as OCV, OCR rather than the way it's written there, because object character verification and object character recognition are both critical here. And OCV is kind of the basic piece of the OCR in a sense. They're two separate things, but object character verification is verifying that the correct number or sequence or written code or barcode or something along those lines are exactly as we tell it to be. So say we're looking for ABC123, we need to verify that that's there every time. And so object character verification is going to know what that object looks like, and it's going to verify that it's there in the presence that we're calling it to be. Object character recognition would be something like we're doing a sequence. So 1 would be the first part, 2 would be the second part, 3, and so on. And so object character recognition is going to verify that ABC121 is present, then 122 is present, 123 is present. And it knows that it needs to count in a sequential function based on what we're telling either the processing unit to sense or the PLC that we might be communicating with. Again, we'll talk about all of these in a little more detail in later videos, but this is just kind of a basic, rough understanding. And that concludes our beginning introduction to machine vision. So thank you all for watching, and stay tuned to upcoming videos.